Hi Geometry, we are starting section 3.4 and we're on page 272, so go ahead and open your books to that page. And once you do that, if you notice we have 4 points A, B, C, and D that they want us to plot on this coordinate plane. So why don't you go ahead, pause the video right now and plot those points and then come back when you're all done. Alright, so hopefully you've paused the video and you came back after you plotted. So point A should be at -5, 4. I'm going to label that plot A. Point B should be at -5, -4. And that's point B. Make sure you label it as well. Point C is at 6, -4. And point D is at 0, 4. So they want us to connect all the points in alphabetical order. So I'm going to go from A down to B, and you should be using a straight edge when you do this so it's not freehand. And then from B to C, and then from C to D, and then from D to A, close that up. So if you look here, it looks as if we have a figure that looks like a trapezoid, and we can say that because the line segment AD and BC are parallel, they're both horizontal. So I'm going to go down and explain how you know that the quadrilateral is a trapezoid. I have one pair of opposite sides parallel. Remember, this symbol means parallel. So that our top and bottom are parallel, those are the bases. So if we go to the very next page, at the top of our next page here, we know that a trapezoid has exactly one pair of opposite sides parallel, because the non-parallel sides, they come in and eventually they're going to intersect. So they want us to identify what the bases are. So going back to our picture, our bases are the two segments that are parallel to each other. So segment AD and segment BC are our bases. So let's go ahead and write that. Segment AD and segment BC. And then next they want to know what the legs are. So the legs are the actual two non-parallel sides, which are the remaining two. So we have this segment AB and the segment DC. So again, like I said before, eventually they would intersect somewhere down the line. So there's the non-parallel sides. So we're going to go ahead and write that now. The legs are segment AB and segment DC. Okay, so next they want us to analyze the trapezoid that we graphed and described how we can figure out the perimeter of this trapezoid. Well, the perimeter, recall, is just taken by adding up all the lengths of the sides. And since we know the trapezoid has 4 sides, we know that we're going to find the length of each of these. Okay, so let's find the length of each of these to determine the perimeter. So all we're going to do is count how many units. So one thing you have to be aware of is to make sure how many units you're going by in the coordinate plane. So it looks like we're going by single units here, 0, 1, 2, 3, 4, 5, 6, and so forth. So every unit that we count are single units. So from A to D, we have 5 units, so we're going to go ahead and write 5 here. We know from A to B, if we start counting, 1, 2, 3, 4, 5, 6, 7, 8. This is 8 units long. From B to C, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units. And from D to C, now unfortunately, DC, it is not horizontal or vertical like these other 3 were. So we're going to have to go ahead and draw our right triangle and find the distance, and that's what we did actually a while ago, is showing you how to use the Pythagorean theorem. So we're going to have to use the Pythagorean theorem for AD. But before we do that, let's say that we know that AB is 8 because we figured that out. We also know that segment AD is 5. And we also know that segment BC was 11. So to find the measure of DC, which is that last segment, we're going to have to use the Pythagorean theorem. Okay? So we're just going to add up those sides, but we can't do that until we know that that fourth side. So let's go ahead and use the Pythagorean theorem. Going back to this page, if I were to draw this right triangle here and over, really I have a right angle, well, I need to count how many units up. Since this length is the same as this over here, I know that this has to be 8 units up. And then also, I know if this whole thing were 11, if I could just count, I know that would have to be 6 units. So really what I'm trying to find out here is the length of this DC, which really represents my hypotenuse in this right triangle, okay? So that's how we're gonna find the side. Now, of course, you could use the distance formula, but since you have a coordinate plane available to you, it's probably easiest to use the Pythagorean theorem. So we're gonna use the Pythagorean theorem with our legs of 6 and 8. So again, back to our next page. So we know that DC is equal to a squared plus b squared equals c squared. And again, we're going to use 6 and 8 for our legs. And it doesn't matter if you intertwine them between a and b. You're going to get the same answer. As long as you remember to use your hypotenuse, which is that highlighted segment DC, which we're trying to find as your c. All right, so 36 plus 64 is 100. And we still have to take the square root. So when we take the square root of 100, we're going to get 10. So that means DC is equal to 10. So we're going to write DC is equal to 10. Now they want us to find the perimeter. So the perimeter is equal to the addition of all of these numbers here, which is 8 plus 5 plus 11, and finally plus that 10. And that will come out to 34 units. Okay, so that's how we find the perimeter of our trapezoid. Now, I know it doesn't ask for it, but I want you to save some room down here, and let's find the area of the trapezoid, because eventually in your homework, it's going to ask you to do both. So let's do that. Recall that the area of a trapezoid is found by taking the height times the sum of the two bases, all divided by 2, which is the same as half of the height times the sum of the two bases. But you may find that writing it out this way works better for you. So let's go back to our trapezoid on the other page and look at our separate pieces. So base 1 and base 2. Remember that base 1 and base 2 are your two parallel sides, AD and BC. So we have 5 and 11 as our bases. All right, so we know we're going to write those in there. So 5 plus 11. And then our height comes from this segment AB here. Because remember, a true height is perpendicular to the base such that it forms a right angle. And even though DC is a length, it's not a true height. It's not perpendicular to that base. So we are going to use 8 as our height, okay? So in place of H now, we're gonna insert that 8. So if we do order of operations, we can do what's in parentheses first, which is 5 plus 11, which is 16. And at this point, you could either choose, hey, let's multiply 8 times 16 and get 128. And then divided by 2, which is 64, or you could say, you know what, I want to cross reduce 8 times, or divided by 2, which is 4. 4 times 16 is still 64. But this time we're going to get units squared. Anytime you're dealing with area, it's 2-dimensional, so it's square units, okay? So that's our area. So we found the perimeter, we found the area. I do want to take you back to this picture here of our trapezoid, because on your homework, you may get a problem where your height isn't true to your trapezoid. In other words, what if they did give us a paper that had a trapezoid that looked like this? So this is a what if scenario. So there's no need to write anything else in your notes right now because you're pretty much done. I just wanted to show you the what if case. So in the what if case, what if they did extend this trapezoid out, and if they asked you to find the area, you're not given a true height. So in this case, your what if case, it's up to you to find that true height. And all you're gonna do is draw a line segment down from your upper base straight down to your lower base such that it is perpendicular to that line. And so this is the height I would want to use for the area of my trapezoid. And again, all you would do is count the number of units, and you'll find that that height is 8. So in that case, we would still use 8 for our height, but you sometimes, depending on the picture they give you, may have to drop down that altitude to create that height and use that as your height in your area formula, okay? All right, well that's it, and your homework tonight is 3.4 worksheet, and have a good day.